Everyone, my name is Sarveshwar Kosuri and this is my submission for the multi-document track system. My goal was to build a robust enterprise-grade backend with a decoupled ingestion and query pipeline to make the architecture 100% efficient, 100% free to run. I moved away from OpenAI and instead implemented local BGE embeddings via sentence transformers and LLM generation using Llama 3.1 via Groq. The entire system is containerized with Docker. So let me show you how it runs. I am switching to the IDE. I'm Docker Composer. I configured a Docker Compose file that handles the environment setup. As you can see, with a single command it boots up the FastAPI server, connects to our SQLite relational database to handle conversational memory, and establishes a connection to our Pinecone vector database. Now I am opening to the ingestion pipeline. uh, as soon as this is the one sec. It's not booted because it is not started at yet. Now it is started successfully. Now I'm switching back to the U URL localhost URL 8000 sagrify. Now first I check the health check by running try it out. Wait. Here is the interactive Swagger UI automatically generated by FastAPI. First, I'll demonstrate the ingestion pipeline and first I'll check the health check. When click the button execute, it return the call command get http localhost 8000 health endpoint and it returns the status okay and content length is 15 and server is uicon. Now I'll demonstrate the ingestion pipeline. I'm going to upload a CSP. Click the choose file. I'm clicking open and clicking execute. It's loading. It's taking, yeah, it's take 3 to 4 seconds and ingested successfully and returns the ingested successfully. File name is c8.final.csp.pdf, which is we uploaded. Document ID is created and chunks are processed 89. When I click execute, the backend parses the PDF using PyMuPDF to extract the text while restricting preserving page numbers. It then splits the into text into 1000 character chunks with a sliding window overlap. Embeds them locally into 384 dimensional vectors, pushes them to Pinecone. As you can see in the server response, the document was successfully ingested. This is the Pinecone. This is the documents and ingested. I checked this project before, that's why it's This is how it works. Now I'll query pipeline. I'll check the query pipeline and citations. This is the chart endpoint. I'll click the try it out button. This is where we have to enter the query. What is the what is title? Question one is query one is like this. I am setting the session ID as 2 session ID 1. Now I'm clicking the execute button. It's loading. uh, this is the query, this is the session ID. The answer, it gives a code number 200 giving the answer. The title of the community service is not explicitly. It will be agri-based mobile apps and their impact on agriculture production and farmers livelihood security from the chcsp. The title of the answer is given like that. The title of the community service focused on agri-based mobile apps and their impact on agriculture production and farmers livelihood security. This is the title of the. I'm asking the another question like, what are the names of the agri-specific agri-based apps demonstrated to the farmers in the project? The specific algorithms demonstration formula is for included whether for customer market analysis target. Additionally, Agri and Agri-Media were mentioned as the examples of the used apps by the farmers, with Agri-app having a rating of 4.3 out of 5 from users and providing a chart option from for farmers to easily chart with an aspect of agriculture. These are the document citations, like it is retrieved from document name CA page number 26, document name CA page number 28 and page number 30. This information is retrieved from the concern pages. I will ask the system to find the course code name of the. I just uploaded. Wait, when I hit executed, it embeds my questions performs consume cosine similarity search against Pinecone and retrieves the top 15 most relevant checks. It then injects those chunks into a strict prompts for Llama 3.1. Notice the JSON response. It successfully extracted the answers, and more importantly, it returned the programming tick citations indicating exactly which document and page number the information came from, fulfilling the core traceability requirement. To demonstrate conversational memory, I will ask a follow-up question using a pronoun. So this is the follow-up question, and I'm checking the anti-hallucination guardrail. Change the query to like what is the capital of India with different session ID. It returns the answer like I could not find an answer in the provided document session ID. So it doesn't hallucinate. And let's test the anti-hallucination. I will ask it how to bake, what is the capital of India, and it returns like I could not find an answer in the provided documents. That covers all the core requirements of the rubric, from the decoupled pipelines to strict JSON citation formatting and hallucination prevention. The source code is available in my GitHub repository. Thanks for watching. Thank you.